The next unit that we're going to go over is understanding binary code. You should go to the folder under binary code in Angel and print out both worksheets relating to binary code. You will want to take notes over all this material because, once again, this is what will be on the test. Just like everything else that we've done, you'll have a review test over these notes, which will be untimed, and you can take as long as you want and take it as many times as you want to review. And then we'll take the final test, which will be limited in time and which you'll have to get done fairly fast. You'll have about 15 seconds per question to answer, so you either know it or you don't. A lot of times students will ask, well, how will I ever use binary code? And the truth is, you might not ever use it. But as a communications class, we do want you to understand what binary code is. Binary code is the computer language that a computer understands. It is the only language that a computer understands. When you type a word into the computer does not understand that word. However, that word has been translated into binary code, then the computer understands it, and it will send it back in binary code, and then it will translate it back into English or whatever language you're using. What makes the computer so special is that it does it very, very fast. So again, computers don't understand this, but where there are programs that translate between binary and language. Binary code is made up of binary digits, commonly abbreviated as a bit. So we take the B from binary and the IT from digits and combine that together to get the word bit. If you imagine the bit as a letter, when we combine other letters, it creates a word. Bits are similar and they combine to do more. If you saw the movie The Matrix, and most people did, or if you look at the background of this slide, this is what binary code would look like. And at one point in our history, people had to translate this so they could understand what the computer was doing, and so the computer could understand what they wanted them to do. It may seem a little bit confusing at first, but the people that do this understand it. A bit can only be one of two states. It can be a 1, which represents on, which means that the power runs through it, or it can be a 0, which represents off, meaning there is no power. Computers cannot understand anything else. If you think of each bit as a light switch, you have a light switch on the wall, and that light switch can be one of two things. It can be either on or it can be off, and that's what a bit is all about. It is on or it is off. By combining 8 of these bits, you form a byte, and again, another common term in computer technology. And this represents the computer's memory or data. Early computer memory size was given in kilobytes, which is 1,000 bytes. Beyond kilobytes, as technology has allowed, we've developed more and more memory. And these will be on the test, and you will want to write these down into your notes. Megabyte, which is 10 to the 6th power, is 1 million bytes. And at one time, this was the common term used to tell how much memory your computer has. In today's world, we go to a gigabyte, which is 10 to the 9th power, which is 1 billion bytes. And this was fairly common as recently as a year or two ago. If you're buying a new computer today, it goes in terabytes, which is 10 to the 12th power, which is 1 trillion bytes. And this again tells how much memory the computer is able to store. It will also relate a little bit to how fast the computer will go and other things related to it. Now these three terms, megabyte, gigabyte, and terabyte, will be on the quiz, and you are expected to have at least a little bit of knowledge of what they are. However, it's believed that we're improving our memory each year by about 60%, so it won't be long before we start getting into other memory sizes. Future classifications that you'll start to see in your lifetime but will not be on the test are petabytes, exabytes, and zettabytes, and yottabytes, which sounds a little Star Wars-like. But again, as the memory improves, the computer will be capable of doing other things. Another thing that we're going to talk about a little bit later down the road is the advent of fiber optics. And fiber optics is much, much faster than copper wire, which is probably coming to your home right now. One of the things that's slowing our ability to move around on the internet is how slow electricity goes through the copper wiring. Once we go to fiber optics, we'll jump up to the speed of light. Not only that, but we can send 7 messages at the same time, 1 in each different color of wavelength, and we'll be able to go much, much faster on our computers. We're not quite to this stage yet, but this is looking at the future and some of the things that might happen down the road. Now, some of the things that we look at as we get better memory is incredible speeds of the computers. It is believed that eventually the computer will react almost as fast as you can think. Also, I've got a typo there, excuse me, I'll try to fix it. Hard drives will be the size of a grain of salt. So these could be implanted in a lot of different things. Now students always think, well, if it's a hard drive is only as big as a grain of salt, how am I going to see the screen? How am I going to see the keyboard or type or anything like that? And those will become obsolete. We'll be using those hard drives for different things. We believe that computers will be able to be embedded into different things, and this should be on your notes. We think we can put them in the tables, in the walls of your home, in the clothing that you wear, so that they'll be constantly checking your health and looking for any health problems or injuries that might happen. We can put these computers into buildings, and eventually these buildings will be able to react to the weather outside. So if the weather outside is very nice, homes have what's called an R value, and R value is the resistance to the weather. And we want to have a fairly good R value in our homes so that if it's cold outside, you're comfortable inside, or if it's hot outside, you're still comfortable inside, or whatever the situation might be. Well, they think that in the future, buildings will be created so that the computer can actually cause the walls to react. So if it's a beautiful day outside, the walls could become porous and fresh air could come into the home. Once the weather changes, or there's bad weather, or there's high ozone days, or there's pollution, or whatever it might be, the computer could change the properties of the walls and convert them to where they would seal back and enclose the home from the outside elements. And the possibilities are going to really be unlimited as these things start happening. A lot of my students say, well, I don't believe this and I don't think that's going to happen, but you will be amazed at some of the possibilities. And as we talk about these, I can't predict the future, and I don't know what's going to happen in the future, but I do know some of the things that the scientists are talking about that they believe could possibly happen. And that's what we're going to look at as we go through this class. Now, to summarize this real quick, binary code uses only 2 settings, 1 which would be on and 0 which would be off. While that may seem very simple, it's how the computer communicates. Using only these 2 characters, we create codes, and those codes then can represent letters, numbers, colors, music, and much more. So once we have that 8-digit byte and we have a code in there, somebody has programmed that so that a certain code equals a letter, or in a different setting that code could equal a number or a color or a note of music. Now, we want to look at the number of combinations that we can get for every bit. So again, let's refer to the light switch on the wall. So imagine we have the light switch on the wall. That light switch can be on or it can be off. So we have 2 combinations when we have 1 bit. If we have 2 bits, we have 4 combinations. And again, if you have a light switch on the wall that has 2 switches on it, you can find, and you can play with that there are 4 different combinations that you can get from that. You can have 0, 0, which means both lights are off. You can have 0, 1, which means the left one is off and the right one is on. You can have 1, 0, which means the left one is on and the right one is off. And then you can have on, on, which means both light switches would be on. Now, as we look at this, you're going to find out that this goes up really pretty quickly. So this is a chart that you want to put down into your notes. And some of it is already filled out and some of it is not. So if you look on the handout that you have, you'll notice there are two basically columns. The one on the left says the number of bits is 1, 2, a blank number that you're going to have to figure out. The next one will be 4, so you have 1, 2, blank 4, and maybe you can figure out what number goes in there. Then you go over to the next column of bits, and it goes 5, blank, 7, and 8. And you're going to want to write this down from the chart up here on the video. Then you notice the combinations to the right. So with 1 bit, we have 2 combinations. With 2 bits, we have 4 combinations. With 3 bits, we have 8 combinations. With 4 bits, we have 16 combinations. With 5 bits, we have 32 combinations. 6 bits create 64 combinations. 7 bits, 128 combinations. And 8 bits, 256 different combinations. So this really will accumulate very, very rapidly to give us a large number of information for whatever we're doing on the computer. Now again, we don't care about this. This is already done for us by the professionals. If you're going to go into this area, you'll learn about this quite a bit. But again, for what we're doing, we just want you to get a general understanding. When you go buy a computer or you're buying a game or whatever it might be, a lot of times you'll see on there that it will say this is an 8-bit or a 16-bit or 32-bit program, or 64-bit I think we're up to now, and it will give you a little bit of idea of how massive the information is that's going to be stored on that computer or game or whatever it might be. Now, this combining of groups of bits allows for many more combinations, as we mentioned, and this is referred to in programming as the powers of 2. So 1 byte, which is 8 bits, can represent all characters from 0 to 256. So again, the professionals have created that all of these numbers would relate to letters, numbers, sounds, colors, or whatever it might be that they can use. So let's look at the example of 4 bits, which is 16 combinations. Now, I'm not going to go through all of these because I'm sure you can look at them and see what they are, but here are all of the different combinations that we can get out of a 4-bit system. And you go all the way from all 4 of them being off, in the top left, over here, and over here we have all 4 of them being on, and then in between we have the combination of all other possibilities. You will be expected on the quiz to come up with all of the combinations for a 3-bit system. So there would be 8 combinations, and you're going to have to figure those all out. I'm not going to become excessive on this and expect you to go to 4, 5, 6 bits or something like that, because it really is a pretty difficult task to sit there and go through all of these and organize them. But again, this has already been done for us by computer programmers. Now, information, to summarize, is organized into groups of 8 bits, and this is called a byte. Again, I neglected to point out, but if you see information in red, that's information that should be in your notes, and if it should be in your notes, there's a pretty good chance that it's going to be on the test. And this is the memory of the computer. It also relates to some other things, but we're not going to worry about that. As computers have gotten better, we've moved up to 16-bit, 32-bit, and so on. And again, these are only going to increase and only going to go up. But to keep it simple, we're going to focus on just an 8-bit system, or 1 byte. Now, this is the completion of Binary Code Notes Part 1. You'll want to make sure that you printed this out, taken your notes, and you're ready for the test. When you're ready, our next video will be on how to decode or translate binary code. So you're going to actually learn how to read binary code, and that will be on the test also. Now, fortunately, in real life, programmers have already created the language to do this for you. But again, as a communications class, we want you to understand how it's done. When ready, go ahead and open and take notes over translating binary code video.